Okay, here's how this fits in with right triangles. We do a lot of work with right triangles in geometry. That's a big part of what you guys are studying. And so know this. This is the only reason I'm telling you this is so you know where you've come and what you're doing and why this fits in where it does. Pythagorean theorem, number one. That's the number one thing we try to teach you about right triangles. First thing we do. You will have two sides, and you will need to find a third side. And you know how to solve that, I believe, right? And so we've worked on that. You know that one. That's pretty easy. No problem. The next one that we work with is special right triangles with 30, 60, 90, 45, 45, 90. It's the rules are now provided on the tax sheet, and those are their own little deal. And you can identify those because two sides in a triangle are congruent, in a right triangle are congruent. That's a 45, 45, 90. Otherwise, they'll have a 30 or a 60, and you'll identify 30, 60, 90, and you'll apply those rules. This that we're talking about today is the most powerful of all. It's the trig functions, and it'll be available to you to use when you have a right triangle and you have one side given and one acute angle given. So you know it's a right triangle, that's the 90. You have one angle, one side, and you need a side. Or you have two sides and you need to find a missing angle. All right? Don't forget when you're trying to find the angle, you're going to have to use that second key. The other thing that I need to tell you up front when you're working with calculators and trig, you need to check your mode on that calculator and be sure that your mode is in degree. If it's not in degrees, then you're going to get all wrong answers. You got one already? You need one. It's a calculator problem. All right. When I learned this lesson from my trig teacher in high school, she taught us about the Indian princess of right triangles, Sokotoa. And that's how I've memorized it ever since. And so when I encounter one of these problems, I immediately write Sokotoa on my paper. What I've got on the board here is all of the information that comes with that memory. Okay, it's the trig functions sine, cosine, and tangent, and it's the ratios that come from each of those functions. So in sine, that's opposite over hypotenuse. In cosine, that's adjacent over hypotenuse. And in tangent, it's opposite over adjacent. And so just to memorize that, it gives me all those ratios that I'm going to then apply to my right triangles. And so let's look at three problems. And if we do that, then I think you'll be able to work any problems that you get from that point forward with right triangles when you're dealing with trig ratios. Let me make sure I've got a pen that's going to be visible. So probably this red one, yeah. All right. Here are the steps that you're going to need to use. This is the key. Number one, identify the sides. Okay, if you look at the trig ratios, you see that we had opposite, we had hypotenuse, and we had adjacent. That's the three things that are going to happen. And so when I get to a triangle, the first thing I want to do is identify the sides in terms of those sides, opposite, adjacent, hypotenuse. And always start with that one. I'm always going to draw an arrow straight from my right angle to the side opposite, because if I do that, I've already identified the hypotenuse. They always start at the 90, arrow across. You have now identified your hypotenuse every time. I do that in every right triangle problem that I have because it's important. That's a different animal, the hypotenuse. All right, so that's the easiest one to identify. The others you'll identify from the vantage point of the acute angle that you have. And so what I like to think of back to my days in high school where my teacher told me about the land of right triangle is that I'm going to actually go look at this land from the viewpoint of that angle. And as I peer out over this land of triangle from here, then obviously from me, this becomes the opposite of me. And that leaves only one side. I've got hypotenuse and opposite, and that would make this one the adjacent. The adjacent one will be the side that I'm touching that's not the hypotenuse. Okay, it's always going to be that way. The opposite is the side opposite. I'm going to go ahead and do step one for all of these triangles so you can see how this works. From this angle, what is this from me? That's opposite, and so you see how easy that is, and that makes this what? That makes that one the adjacent. That's exactly right. So if this is 28, and what is this from me over here? That's the opposite, and that makes this one over here the adjacent. Okay? Easy enough. We got the sides identified. The next thing is to decide which one of these trig ratios I'm going to need to put into use to solve this problem. Okay, I need probably a different color to do that. Again, they're going to have two of the three parts of the triangle are going to be used. This time there's an x here, I need to know that. There's a 14 there, I have that. So on this problem, I'm dealing with adjacent and hypotenuse. And so that's when I go back and think about SOHCAHTOA, and I think about which one is A and H, adjacent and hypotenuse. Which one would I use here? Okay, so I now have identified the trig function that I want to use for this problem, cosine. Let's go ahead and do that for each of these. From this one, I've got a 34 here on the adjacent. I've got an x on the opposite, so I'm dealing with opposite and adjacent. Which trig function would I be using? So this one is going to be tangent, and for this one, I've got a hypotenuse of 15, and I'm looking for opposite, so it's opposite and hypotenuse, which would be sine. Okay, amazingly how I had three different triangles, and I'm covering all three different trig ratios. Okay, so we identify the side, we decide which trig ratio. Now we're going to set up a proportion. In my opinion, solving proportions is very simple, and it's very consistent, and it leads to confidence, I think, with solving these problems. So to solve the proportion, or set it up, let's go through that with this. I'm using cosine, and I'm using cosine of the angle that was acute that I worked from on this triangle, which would be, what's the angle in this case? It's 36. So the cosine of 36 degrees is equal to, and then I think back to the ratio, cosine, ka, A over H. So from cosine, what's the A? So it's 14. Remember, it's a ratio, so you're going to write it like a fraction. And H is x in this case. Okay? When I set that up, here's how I make this a proportion. Every time I work a trig problem, I put that over 1. And now I've got a four-cornered proportion. All right, I'm going to go ahead and set the other proportions up before we solve. Let's set this one up. Tangent of what angle? 42 degrees is equal to, and I'm going to set my ratio, TOA, what goes on top? Opposite, so opposite of 42 is what? X, and then adjacent is 34. And then I'm going to make it a proportion by just drawing a line and putting what? That's all I'm going to do, just put 1 right there. Now I've got my four-cornered proportion going on there. I need a little room over here. All right, sine of what angle? Sine of 28 equals, so opposite on top, which is opposite is what? Is x in this case, and OH would be, H is what? 15. Put this over 1. Here we go. Okay, now set up proportions to solve each of these. And now here's also the easy part, I think, the easy part of solving proportions. Now is a good time to check your calculator and make sure that the mode is on degree. Hit mode, check it, make sure it says degree. Okay, now, every proportion that I try to solve, simplest rule, unless I've got multiple terms in one of those corners and I've got to distribute or something like that, I'm going to cross multiply, and I'm going to multiply the numbers that are across from each other. In other words, I'm not going to mess with the value that's across from x yet. I'm going to multiply the numbers in my calculator. So 14 times 1 and hit enter. When I get the value of, I get that product from multiplying those numbers, I'm then going to divide by the number that's across from x. And that's all that is. Cosine of 36 is just it's a number. So now hit divide by cosine of 36. There's going to be a fraction or a parenthesis here. You should close that parenthesis at the end. Hit enter and tell me what you get.
17.30.
Okay. Is that what everybody got? So they may ask you to round that to tenths, and it'd be 17.3, or to hundredths, and it'd be 17.30, but that's how that one works. Okay, this one is different than that one a little bit, and here's why. This one is not. No, yeah, they are. Why is this one different than this one? Because this time when I looked up, then the numbers that were across from me included the trig function. Whereas this one, it was 14 times 1, and I divided by the trig function. This time I'm going to punch in tangent of 42. You must put the parenthesis on the end of that, and then multiply it by 34. Tangent of 42, close it off with the parenthesis, multiply by 34, hit enter, and then obviously what's the number that's across from x right here?
1.
But if you divide by 1, you're going to get the same thing that you already have. You're welcome to do it, but it won't change the value. So these two are going to work exactly alike. What happened when you did this tangent of 42 times 34?
30.61.
30 point.
61.
Is that what everybody got? Okay. Feel pretty good about that then. All right. Go ahead and finish this one. You're going to multiply sine of 28 times 15, because those are the numbers across from each other. Then you can divide by 1 if you want. It's not necessary. And then tell me what you get on that one when you multiply that out. Jordan, you got it?
7.04.
Is that what you got? Is that what everybody got? All right, just a little something for you to check out right quick. And this is not, that's SOHCAHTOA. That's the whole lesson. That's the way they're going to work. That covers every single one of them. If you understand the proportion, you can apply it every time. This tells you when you should use it. That'll work for you, I think. Does anybody have any questions that you see? Does that help? Okay, now look here at if you have this side and this side, then how would you get that side? What theorem is that? What theorem is that when you have this and this and you're trying to get this? No. When I have two sides and I need a third side in a right triangle, remember that's the first one we talked about when I told you when you studied right triangles. That's Pythagorean theorem. Now a little calculator trick on this. Let's find this side, even though they didn't ask us when we first did, just because we can, because we understand Pythagorean theorem. If I'm pointing at a number in Pythagorean theorem, if I point from my right triangle and I point at a number, I have to put it in first. So put that in your calculator, 15, and square it. Don't hit enter yet, just put 15 squared and then put minus and put 7.04 squared. And then to find this one, you hit enter and then hit rooftop 0.5 and then hit enter, and that'll give you that number right there. What number did you get? Okay, I think that sounds pretty good. Is that what you guys got? 13 point. So 15 squared minus 7.04 squared. Enter rooftop 0.5. Rooftop 0.5 is a great way to find the square root after you have the value in your calculator. It's better, I think, than using the second key to do that. Okay, before we stop, let me shoot one more problem at you, because this is going to be one that's going to come up when you're dealing with trig functions. And I get this question a lot. How do I find the angle? Probably have a better pen. If you have a right triangle and you have two sides and you need to find an angle. So this time the variable's inside the triangle at one of the acute angles. Let's say you have 12 here, and 20 right here. Okay? This is still a trig problem. Only difference is I have two sides and I'm looking for an angle. From here, I still want to do the same thing that I've done. I'm going to identify the parts of the triangle. What am I pointing at right here? That's the hypotenuse. That makes this is the angle I'm dealing with. What is this 20 down here? That's opposite. And what is this 12 now? That's adjacent. So now that's going to tell me which trig function I can use, because the ones I'm dealing with, there's a 20 and a 12. It's opposite and adjacent. So which one would I use? Okay, it's tangent this time of x, because I don't know that angle. All right, but the ratio is from here, tangent is opposite over adjacent. So it's 20 over 12. But I don't need to cross multiply or proportion or anything right here. What I need to do is hit the second key. Just hit second tangent, and it's going to have a parentheses there, and you're going to use division. 20 divided by 12. Close that parentheses, and then hit enter, and that'll give you the value of that angle. What did that give you?
59.03.
Okay, 59.03. Now, if you knew that was 59.03, what is this angle?
90.
Can you figure out this angle over here?
30.
Because, how'd you do that?
30, 60.
Pretty close to 30, 60, 90, but actually that'd be like 31, because the three angles in the triangle are always going to add up to what?
180.
To 180 every single time. Okay, I hope that helps. There's your trig lesson. Sokotoa, land of right triangles.